If identifying weld joints and weld types is really confusing, that's okay. Like just be patient with yourself. And I think getting through all these problems this week will help. But you know, the reality is you're still going to be pretty unclear on things. And the most important for the ADDA testing is just to be able to recognize weld symbols and kind of how to build them and what they mean, some of the hieroglyphics. But first, we're just going to play around with inventor still. So I'm going to build a new part here. So I'm going to do what? I think I said I do problem 15.1 here. So I do think I have the imagery up for these now all the way through here. But I also said if we can't get to all these this week, that's okay. I do want to just analyze them really good and do them all thoroughly here. So this one is a special one that I kind of did two different assemblies of it using the same parts because I showed you how, and I talked about it yesterday, how normally we don't show the welds, but what I'm communicating when I don't show the welds is like what's going on the left side here, and what's actually happening when the welder gets it is what's going on here on the left side of my drawing. So this is how my part will look like when I go out and look at it in the shop or whatever. But this is really how I usually designate it in a drawing and how I normally build my assemblies without the welds shown. So let's do both on this one. And essentially this has the I should have uploaded the PDF. I should do that because some of these you may not be able to zoom in enough to see, but I hope that the dimensions that we need to make the parts are in this drawing as well. Essentially, this is kind of an oddball shape as well. It's kind of long. It's like the part itself is what? 6 inches by how long? I don't show how long, do I? Oh, well, I suck at this, dude. Yep. Infinitely long. It's 20 inches. I know that because I know it's like this oddball length. Unfortunately, I should have added that dimension on here. So I do feel like now I'll have to go through and double check all mine that if you're going to work ahead of me, that your dimensions are there. And so I will upload, well, even if I upload the PDF, I wouldn't have to either. You don't know. But these are 20 inches long. Okay, let's do this. 20 inches long. They're 6 inch parts. How thick are they? I do have them their 1/4 inch plate, kind of. And the reason why I've like loaded you'll see that like one of the resources on all these assignments is like a Pacific Steel manual, and I'll open it up in a minute. But the reason why I uploaded that was because it shows you how to write steel designations. There is kind of a right method to how you write uh, to call out steel, and it's usually thickness by width or length. So this is what I'm saying here is this is 1/4 by 6 mild steel flat. And I've added that description into the part, I properties. But to know how to designate steel, it helps to look at a steel manual and and I'll do that once I really worry about what this particular material is. Then I'll update the I properties and I'll look at that manual. But first, all I need to know is that it's 6 by 1/4 by 20 inches long. Sorry, I don't have that on. I'll check my other ones with a fine tune check on this afternoon. So I just in my part file, so a new part that I just created, just a new standard part, and I'm gonna sketch on that XY plane. And this is same, just a rectangular part of steel, but it's 20 inches long, so super long, and it's 6 inches wide. It's 20 by 6 is what this one is. Mm-hmm. And I'm gonna constrain it over the origin as well here. So I'm just gonna go origin point here, vertical origin. And then I've got my part over center plane. I only need one part to build assembly. It's all just the same part on itself. So I'm going to finish this, and then I'll extrude this. It's a 1/4 inch thick. I'll just extrude that 1/4 inch over center plane. Oops. Now I've got my part that I'll save. Save that sucker in week 4 in my parts folder. This is exercise 15.1, part 1. It's a class for me. And then I just need an assembly, and I can do the welding assembly. Yeah, so I'm gonna go to my home and open up a new weldment assembly so I can show some welds. So I'll do the welded one first, and I'm going to place my part in here. So I got to assemble and place. Just in place. We haven't placed from anything else yet, but just simple place for my folders. Here's my in class part 1. And I just need 2 of these. Technically on my drawing, I have 2 different assemblies. I didn't put them in the same assembly. So I just dropped 2 of these parts for my simple assembly here. I change this to shaded edges. I'm gonna assemble them the same way I did on the exercise there. So I'm just going to constrain these the exact same way. That'll look good. Just edge to face here, and end for end lineup with flush, and then I'll use the planes. This plane to this plane, this one right here, and this flush, and that's the end of my. Like that's as far as I took the other assembly actually, and then I just detailed it out. But we'll do the welds in here. And so what you have is you kind of need to know you need to be able to know what the heck this weld is even saying in this on this assignment sheet. So let's talk about welds, which you will learn about in chapter 18 a lot. So this is saying that what I have is this is the weld symbol right here. Basic weld symbol kind of has like a I should look up the right parts name, right? I'll check your book here. But I'll think of some questions that I see in here. Just the reference line and the leader line, I think, and then they have a tail. This one does not have a tail. So I'm looking at page 621 for a reference. It's right after the weld processes are talked about. It goes right into this weld symbol. And so this is the basic weld symbol with the what we'd call, if I zoom in here a little bit, I'll zoom in. So I'm just looking at this little piece of literature on my drawing. This is the weld symbol. This is the leader. They just call this the leader, like you would on a multi-leader line. And this is the reference line here. And it's always horizontal. Reference line always horizontal. The leader line kind of can change around like a leader line can. 45 is my target, but if I have to adjust that, it's okay. It kind of adjusts like a normal leader line in Inventor or CAD. But the reference line always stays horizontal. And then what I have is a top and a bottom of the reference line. And this is how I designate arrow side or other side. So my leader line is going to point to one side or the other. And then I can communicate the welding that's happening without having to do like a weld symbol on both sides of something that gets welded. And in this case, both sides of our T joint is going to get welded. So I'm able to do arrow and other. I can differentiate between those two sides. And so this side is symmetrical. I mean, I'm going to do the same thing on one side as the other. And so you just have to learn that the bottom side is arrow side. So any information below the reference line on the bottom is what we call arrow side. That means wherever that arrow is touching that on that joint, that is the arrow side. And then the top of the line is other side. And they just call it arrow and other side on the welding symbol terminology. So arrow side, other side. So this tells me that I'm doing like and then you start to learn these hieroglyphics of what the heck this freaking triangle means. And let's see on your book where they start to break those down. 623 is all the different symbols I can use above and below the reference line. Or sometimes just one side if only one side gets welded. It could be the others. And you can even point to the other side, or sorry, point to an arrow side, but actually only weld on the other side. Because sometimes that's just the only thing I can get into, especially as a drafter, to apply the weld symbol to. And anyway, so we have, what you'll learn now and what ADDA likes to test you on, obviously, are some of the symbology that's on 623 in your textbook. Fillet welds, square welds, scarf, V's, bevel, U's, J's, flare V's and flare bevels, kind of specialized cases, plug or slot. I mean, there's a lot. Edge, flange, corner flange, stud, surfacing, spotter projection, seam welds, back or backing. And then they give you a few other little add-on things. That's figure 1813 that I'm looking at. 1814 kind of has a weld all around symbol, a field weld symbol. If something can't be done in a manufacturing shop, it has to be done on seam. Melt through is kind of like a back or backing, but different. And you can see there is some overlap in symbology. See, it gets kind of technical. A consumable insert to square, that's a real specialized case. Backing or backing, okay. And then we have like what you were talking about, like if I needed to grind something out to be totally flush, here are some symbols that I could apply over the top of even the welding symbol. So some of the symbols in 1814 are actually used in conjunction with what's going on in 1813. So some of these are like, they can both be applied to the same weld. You could have, flush, it has to be flush ground, convex ground, contour. I can specify, so the other thing now if I'm looking at 622, it really breaks down all of the particulars of a weld symbol. Yes, we have arrow side, we have other side. We have a tail. This particular one doesn't have a tail. That would be like over here, opposite the leader side. There's a little V tail that can be added, and you can add notes into the tail. So there might be some process designation there. There might be some C note, blah, 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 and it could point to like a general note tab on your drawing or something. So it's just a tail section in order to pick up more information, more details. And then the stuff that's on the side of the symbol. So in this case right here, what I have is a fillet weld symbol. Fillet weld looks like a triangle. It's always drawn this way, whether my leader line's on this side of the part or this side of the part. It always has a straight line up and down on the left, and then it's angled. So that one, it never like switches directional. It's always like a right triangle with the left side being as straight up and down. Then if you only have one side, you just have one triangle here, arrow side. This one shows a fillet weld both sides. And then that has a number right to the left of that straight up and down symbol. And that just means if I look over here, if it's in parentheses over there, it could be the effective throat. That's that weird thickness that I pointed out. And the otherwise, it's usually the depth or preparation or size. And in a fillet weld, the size there is the leg length. So that's a 1/4 inch fillet weld is how I'd read that. And now this one's more complicated than what he did in the first exercise, but it has a 4-8. So if I look at this page 622 in your textbook, that shows that if you have like a number sequence there, the first number is the length of the weld. So in this case, it's a 4-inch weld. This is in inches. And then the 8, if I'm looking at page 622, is the pitch, which pitch, if you think of threads, was like thread to thread as a pitch. Well, in a weld, it's like center to center. So that means that's a 4-inch weld on 8-inch centers. Okay. So that's what I've got to apply to my weld here. So I'm going to go back to my weldment, and I'm going to have this thing up on my other screen. And then I'm just going to apply that weld. So it's a fillet weld. Yep, here's my thing. So we want to move into the weld function and apply a weld to this thing. And it's a fillet weld. And then it brings up this browser, which really you're just loading up welding symbols, what you're loading up here. That's why this is user-friendly to me more than CAD. CAD doesn't have this. So it's harder to me, it's harder to understand how to learn weld symbols without Inventor. But it's like, oh, these are going to be 1/4 inch weld. So actually I have mine was preloaded from 1/4 inch the last time I used it. This is my first surface. And this is going to be my second surface. I've just chosen either side. They're actually both going to be the same. So there's my 1/4 inch weld. Don't really need to enter another one because they're the same length. The contour, I'm going to put as flat contour. It doesn't necessarily say that there, but this is going to be my go-to unless otherwise. Like it's always going to be flat to me unless I really have a need for it. And then this is the intermittency. So this actually shows kind of that thing. Like the first weld is going to be how long the weld is. They've kind of got this little, if you look at your dialog box. So that's going to be, you can do it by decimal, I think. It's 1/4 inch long. I think you can also do fractional as well. Oh, no, it's 4 inches long. So you got to do whole numbers, 4 inches. I think in here you could do fractional, but I'll just keep it decimal. And then this other one is the pitch or the spacing, like center to center, and it's an 8. And then it kind of breaks that weld up like that. I don't think I did any offsets on this. I think this was all I did. There's something that I think just the length of my stuff, it works out. I don't have to do any offsets or worry about partial weld or whatever. I think this is. Then I can say apply. So that is one weld. Even though my weld symbol is going to capture both of them at once, in this particular, I have to do them both. So, and that would make sense. Like a welder can't do both sides at the same time. They've got to do one side, then go to the other side. It's the same way I have to build it in a weldment. It is kind of considered a second weld, even though my weld symbol is going to carry both sides and kind of be, even simplified in some ways. But, I should have just kept that up. So I'm going to do another fillet weld with the same setup. And I'm just going to keep them. They're going to be on the exact same spot on the other side. So these are just called like I don't know what they're just. I'm not specifying that they should be welded opposite of each other at all. I'm specifying that they should be like the exact opposite sides like this. So really my settings is all okay. I can just say okay on this. What I want to point out, I don't know where this is in your book, but I can stagger those. But your weld symbol, if I go back to my image here, if you wanted those to not be on the exact same point on the other side, then this symbol, you would skew it off to one side. So the fillet welds would just be like not over the top of each other. They would be staggered. And and that would allow me to like tell the welder to stagger those welds. So I can keep the same kind of parameters, but I would say make sure that you're welding the opposite, the different spot of the opposite side. Why that matters is if I go back to here, is that can help hold a part into an alignment better, like from a welding and deformation standpoint. If I weld in the same place on both sides, it might make common sense that, oh, that maybe that's the best way to prevent deformation. But sometimes we like to stagger the other side welds, so they're just kind of so I would have so I would have weld here, and then I would have weld here in between those two, and then I'd have weld here. It's almost a way to get like the thing actually fully welded out, but half and half on each side. So, I mean, that's a real. This one is I'm not designating that way. I'm designating this way, and this is common as well too. So you just kind of got to watch yourself as a welder. With if I'm working with prints with a weld symbol, I got to watch for that staggered versus not staggered relationship. What I think it's really about the same. Honestly, I just think the reason why we would do some is because I think you get a more continued. I mean, you get most of the thing down if you weld staggered. Like every part of this plate is kind of locked down. Whereas here, if a certain load hits this can deform in this area because there's no weld holding it there. So yes, the welds themselves might hold it here, but this might allow a force to like just like push that thing to where it's now ruined or whatever. And if I actually had weld here and then I had weld here, could it take a load a little bit better? Yeah, I think there's some. Yeah, that's what our welding engineers need to figure out for this because it does matter. I just say it's pretty common to see both in actual industry. So you just have to watch yourself there. This is done as far as an assembly is concerned, so I'm going to save it. It has my welds on there. I need to document it on my drawing. So I'm just going to save this in my assemblies folder. This is 5.1, assembly one, and this is class. Save it. And then we'll jump into a drawing now. So I'm gonna just open up my template, which I have saved in my files here, right? So I'm just gonna open up a new. I'm gonna open up my template from my folder. Then this won't take me too long to finish up, but I will post it up when I'm done. So, sorry, I'm in the wrong folder. Wrong folder. Yeah. Week 4 assemblies. Oh yes, I'm looking for my template first. I gotta remember what I do. I've saved mine right here, and I think I've cleared it up. Open it. Okay. Just like any template, I'm going to save this as the draw. I'm going to save this as my. I'm going to save it right now as a new site file. Save as. I'm going to give it a new name, not a copy as. I'm going to do save as and change the name of this one that I have up there. And I'll put it in my week 4 folder, my assemblies folder. It's going to be named. Oh, I don't have any drawings there yet. Huh? So I'm going to name it the same as my actual assembly, which is like, oh, I don't know, CAD. Mine's kind of a rendered thing. You can always make yours. You don't have to make yours the same name as mine, but this is problem 15.1. And this is, that's all I'm going to say is I'm not going to call it assembly one actually, because I'm going to have 2 different assemblies on here. So it's just really problem 15.1 for me. I'm going to say save. So now I've got it. Yes, problem 15.1. That's my drawing number. Okay, cool. Let's place that assembly on here. Here it is. I'll just place the base view of it. I didn't really consider that. Oh, I never locked that down. Like one thing I never did. I could come back here and do this. Like it's not in model space locked down at all, right? And normally I would. So I think I'm going to ground and root one of these. I'll just do this one here, and I'm going to ground and root it, and that should take over some of my issues with it floating around in model space. So ground and root this. Oh, maybe I can't. I don't know. Oh, maybe I'm in the weld itself. Like I think I got to return out here. I never did finish my weld sequence. There it is, done. Now I should be able to root this part. Quiet. So now I'm at least locked down in model space, so it's not going to float around on me or change where it is. So I'll go back over to my drawing here. I'm going to replace this one, base view. It still might not have me oriented how I kind of want my front view to be. So I'm going to just spin that with my navigation wheel here. I'll just spin this around where I'm looking at an end like this. Yeah. The only other thing I think I added was just like a view like this of that, which is why I don't have the length shown. So I'm going to turn on my view label. And I think I actually put this one over here on my drawing, right? That's all right. Now let's just focus on. I definitely dimensioned this out just to have some of the dimensions, but let's just do the weld symbol first. So over on my annotate tab, I have a symbols palette here, and I want to apply a weld symbol. So I think I have, there's surface finish symbol, and then here's welding symbols. I think if I select this, it's going to allow me to apply it somewhere. I think I can pick the weld here and then point to it like this. And then place it. So these are just left clicks placing. It'll allow you to do a crazy configuration of a leader line. I should have just like double clicked here. I'm just going to place mine like this. And then it's going to apply probably the last thing you used, or this might just be the default. Looks like I had this. Maybe this is the last thing I used. But so this is why I like inventors. It kind of helps you kind of figure out how these weld symbols work. And so if I just use, yeah, last used, or if I said to no presets, maybe it's just blank like this if you open yours. So there's a top of the box has the last preset used. What's this one? No identification line. I don't think I'm going to turn that on or off. I'm just going to leave that as default. This one here is switching sides if I'm only doing one weld. So here's arrow side designation, which is where my arrow is pointing. Here would be other side from where my arrow is pointing. So I think default is it comes in like this, but I should be able to add another one anyway here. So I'm going to work down here. Here's stagger or no stagger. It won't let me do that right now because I only have welds on one side, but I'm going to add one. So this is, I think default's going to put a weld symbol here for me. So this is arrow side weld symbol. So I kind of work this out from here first, I think, and then I work this way or that way because you don't need all of these dialog boxes on every weld symbol. And in fact, this one's pretty minimal data that I really need. What I need, so here, if I select this, here's some of these preloaded weld symbols that I can apply here, which you're also found in page 623 of the textbook. And I like that you can hover over them and kind of get a quick little read on what they are. But I think they probably contain about everything from that book, actually. We need this fillet weld, so we actually have the right symbol by default shown. And I have it on both sides, so I think if I select here and add one, now I've got fillet weld both sides. That means they're going to be, totally on the other same location on the other side as the arrow side. Here's how I would stagger that and talk about how it would look here. This. That's something I might look for on my weld symbol would be like, oh, I'm staggered from one side to the other. Especially if it's not a continuous weld. It's a continuous weld on both sides. This would be how I designate that as well. Just on top of each other. It's really only when I'm doing segmented welds or like intermittent welds that I would have that staggered. It would make sense. So, and then we got to enter this thing. So there's leg one and here's leg one, leg two, and I really only use one or the other if I have an unequal leg fillet weld. And then this one over here is a prefix, which we don't need a prefix at this point, but there is a place where I'd have more information in front of the fillet weld leg name. I think I can just put in right here leg one as 1/4 inch, and I can't remember if this changes to a fraction for me or if it stays decimal. I'm going to put in a decimal and see if it changes to a fraction. And it's the same on this one. No, it does put what you have in there. I would say it's more common on leg lengths. I have to read the textbook to know this, but I think it's more common to designate these as fractional measurements than decimal on welding symbols. But there are some places that I use decimal. I think mostly fractions. I have to read. You tell me if I'm telling you wrong, but I think mostly fractional. But you can also have metric prints where it would just be the millimeter called out, so it would look just like a number. Inch units, mostly fractions. So I'm going to change that to 1/4 inch leg length and a 1/4 inch leg length here. And then because mine's special, this would be sufficient enough for if it was a continuous weld, I wouldn't need to call out what the leg length is, you know. And so, or sorry, what the intermittent pattern is. I always need to call out a leg length. But this is probably as simple as that could get if it was a continuous weld. Ours has the intermittent thing going on, so I just have to know which box is which. This is length, and then this should say pitch. Yeah. Length is 4. We did 4-inch welds on 8-inch centers on both sides. 4-inch weld, 8-inch centers. Field welding symbol looks like a little flag right on this little, it'll end up applying it right where the reference line changes to the leader line. It applies this little flag. That just means it has to be done in the field and can't be done in a shop. So and the other option I have here is I can weld all around. And that's one that can make sense if you have like, especially if you have your ends that need to be welded. And if it's a continuous weld, I don't know. There's reasons why I would apply this weld all around. It's a quick way to say, hey, that's weld all around. You would almost wonder, can I just do one side and then say weld all around? I'm like, yeah, you probably could, but I think that's a little, that's a little lazy, and it would be better to show both sides, the arrow and other side. If I had applied that, it might mean that I do need to seal the ends here. I need to worry about that a little bit. So I'm going to leave that off. I can add additional weld symbols. What else can I do here? Oh, this is kind of the grinding finish profile, convex, concave, or flat, which I'm not calling out there. This closed tail, I think this is what will add my tail, right? If I select this and a closed tail, I don't know. Maybe if I type something in the tail appears, let me just type in. I'm not going to leave this here. But I think once you actually enter some notes, which would be pretty minimal, pretty shorthand notes here, it wouldn't be like a long paragraph or anything. It should just be usually a process is what's really common here, but not always. It is common also to have not need a note if the process is going to be determined some other way. I would just say okay on this. And then it wants me to repeat and go in. Essentially, that's the welding note in this particular weld. All on one side. I think it kind of matches over here. So, yeah, that's it. Then I just added a few dimensions to make this kind of dimensionally buildables minus the flipping. So I need to add, I kind of need to add another view. I'll kind of remind myself that. These were all done in CAD. You know, last year is the first year I moved into Inventor, and so I don't have them. I don't have them perfect yet. But they're not even shooting to size of this. Really. Eight scale. I'm only doing that because I'm going to add a projection view here. I'm going to add so that I can actually tell you what the length is in the future. I might add this one here just so I can just so that we call out a length. And I'll do a little bit of eye properties manipulation here too at the end of this video. Yeah, I just want to add these dimensions. Just a quick overall here. This one is 6. And I added a parts list too. So I mean, this is just getting used to our normal what our life is as a drafter is to do all this stuff here. If there's maybe an overall, maybe that's not as helpful. I don't know what I put on the flip line. I'll look at it, but I mean, you could think that I might have an overall here. If I had 2 views here, should I do here? Or does that conflict with my welding one? Yeah, I don't know. You got to make some judgment calls. Normally we place dimensions in between views, but because my weld sim was kind of taking over that side of my view, could I move that to the other side? Yes. Could I move that over? Yes. I can do all those changes if I need to. But I went overall, and then I think I just did a dimension on what the spacing was. Maybe this line and this line here. Plus I gave a thickness. Still. Really feel like I should do that. Let's see. I might resize this up a little bit. What I really missed that you guys need to know is we have a 20-inch dimension. That's helpful. Interesting material thickness somewhere. It's a bigger thing. Maybe not it's a little bit lazy, but pretty simple part. What did I do on mine? I had that, I had that. Yeah, I could have put typical here, maybe. I actually dimensioned both. I chose typical this time. Needs a parts list. That's where you're going to see that I have some I properties things to so a parts list I'm going to drop. It's going to want to know what I'm saying. Oh well, I want to know. I have multiple things open, so it doesn't know which one I'm talking about. I have multiple like assemblies and stuff open. I really want the assembly parts list right here that I'm going to select. I'm just going to leave everything else default and say, okay. It should say it's going to enable that on my assembly. I'm going to say, okay. And then here's my parts list, which is really just one part. Right? So I'm going to squish this up a little bit. Anyway. But it has no description. So I'm going to go and add some my properties to my part. So I'm going to drive into that. Usually I arrange my drawing to be on my far left. Then I've got my assembly and then I got my part. Here's my part. So it has nothing. It's just generic. So I'm going to say that this is actually steel. I don't know. Let's see what it is. I'll just pick from here. It was just mild steel that I wanted. So let's just see what I've got. Oh, there's aluminums, bronzes, some brass, some copper, concrete, generic. Here's iron, cast ductile grade. Okay, so I don't know what steels I have. I never remember. There's stainless steels, bunch of plastic stuff, and there's just a mild steel. This is like holding up most of our world with mild steel. Amazing thing. And so I'm going to pick mild steel, and then I'm just going to let it be. Sure, semi-polished. That's what it defaulted to for me. I'll leave that. Now, when I go into the eye properties, that should be what shows up as physical right now with mild steel. If I update that, that's how much that part weighs. That's your 25 pounds. It's a quarter inch, pretty thick. You wouldn't think it, huh? You just like send that off to somebody else and be like, good luck. 5 pound part. Actually, two of them together is 50 pounds. Might be your it might be your restriction on lifting. 50 pounds, pretty common restriction on lifting, solo lifting. What else? I just want to change, and I want to add this. I need the description to show up in my on my parts list. So I just need to add the description, and this is why I have the Pacific Steel manual, and why I'm saying this is. We end up saying that this is quarter inch by 6 inch, and I have MS. Sorry, I do this capital too. MS. Sorry. And mild steel is a pretty common abbreviation. SS for stainless steel, not for the SS guards. Stainless steel. MS means mild steel. Mild steel. And then flat bar is a type that I can actually purchase. So I'll show you that. I'll open up that manual real quick. And that's all I really added to mine. And that was just so that when I go to this drawing, it's now I've got nothing showing up. Oh, is this what do I got going on? Yeah, I do got it. So I butted my parts list up to my water steel. One thing I didn't show on that drawing that I think I have showed in my video, but I'm going to put another assembly on here, which is just the way it would normally be done. And it's mostly just for redundancy. It's mostly just for me saying that you don't normally do it this way. You normally do it this other way. So that's why I have two assemblies on the same thing. I think I've over-explained that, but I'm going to keep on this one. Why I chose, why I did. But I break up my drawing with just a simple sketch here, right? So if you go over to the sketch tab, I think you can start a sketch on dang near every tab. So here starts, yeah, I think sketch tab to start a sketch is on the first three tabs. So no matter whatever your tab on, you can always do just a drawing sketch, which is what I do to break up my drawing. So anywhere I am, I can start a sketch. It might want to know what view, because you can do a sketch in a particular view. I'm just doing it on the drawing itself. So I just choose somewhere out in the drawing land. And I've just been doing a line. And I haven't even been doing a constrained line at all. I've just been dropping. These are my one rules that I don't constrain, is that I just leave that line like that. That's just a border on my drawing for another part here. And so, yeah, that's really all I want to show you. I'm going to go ahead and do the other one, but it's just the same way. I'm just not going to do it as a weldment. It's just going to be the assembly with just those two putted together. I'll go ahead and do the weld symbol on it, and I'll end up with something that looks like this. I'll just probably do it off camera. But now that I have a parts list, I should drop my parts balloon onto my part. And essentially, this is just a recreation of this as the way we would normally do it in different assembly. See you guys, see this. So I should do one more thing here. Place a balloon on this part so it can be identified of what I'm talking about. Part one. I'll probably go up a little bit in size here. 8 inches is a little small, 4 inches was a little big. Another size. 3 1/8 and a quarter. 3/16 size. That's my scale. Yeah, so my assembly doesn't have a description to know what it should be. I guess that's what this is pulling off as like a description of the assembly. You can't pull the description of the you can't pull the description of the part necessarily. Um, so I could give my assembly a name to have my view label fill out here. So here's my assembly. I can go into its type properties. And it's going to have a description as well on the project side. Here's a description. And I can just say that. I could do this all caps anyways. Coupon, COUPON. Yeah, this is a welding coupon. That's what I mean. Now that shows up in my, that's what's pulling the description. If I'm in that thing and I say, of course, those are aluminum welds, which are weird. I think I can change that material. But I think you lose the look of the, let's see, steel. If I change that to steel, it ends up looking like that. That's actually what it'd be welded with, those more mild steel. So this is technically more accurate. And probably get me a little more accurate weight too, because the next thing I'm going to just update real quick is just go into the eye properties and update the mass, or have it update the mass. That's a 93-pound part actually. It's fairly heavy. And then go ahead and put this on here. Now I have, oh wait, 17 pounds. What am I looking at? Let me, no. That makes more sense. I was thinking a 1/4 inch piece of plate that's 6 by 20 shouldn't weigh 50 pounds. Let me see here. I think maybe I'm looking at kilograms versus, I don't know. Why does that say, I thought that is what 93 pounds, unless I'm looking at 93 pounds, inches squared. I don't know. This seems maybe more realistic. 17 pounds? Oh, I better check this. I don't know. Maybe I don't even have the material. I don't think I have the material properties set here. Yours does. Okay. It's mild steel, and I even changed my weld to a mild steel, which I think it was aluminum at first, so it would be lighter a little bit. Doesn't show the weld. I think that's, yeah. Yeah, there's definitely some limitations to how they, technically I wouldn't want this to be, I almost want my parts list to be in that same box. Um, so I might mash this up just a little bit, just so that I can leave room for my other, as long as I can get this. And it's okay if it's here. This can move around wherever I actually have my parts list. I'll just make sure it's in the little subdivided area of my drawing. And these can be, if you just double click on that, you're in the sketch to do a little, maybe I'll line it up here with this one. Heck yes, got it. Thanks. That's perfect. Okay. Am I happy? Yeah, I'm happy. Everything's kind of got a name. Crowding my revision history a little bit. Overlapping a little bit here. Okay, good. I'll do one more assembly and just throw it on there, and that'll be the end. But other than maybe I need to update my title, update who's drawn here. So I have material properties I need to to populate here, or some I property, sorry. I need to say that I am the author, so I have at least my initials. Title's not where you change the title on this particular template, but the description I will add. Do I add a description here? I don't think I need a description. Mostly just need my name and today's date is what it's picking. That's great. I need to change the description here though. This can almost be what I did call that, which is welding coupon or something. Just something for my title. Could say mild steel welding coupon or something, but this particular assembly, like you wouldn't necessarily need another parts breakdown. I mean, it would. I mean, if you're a real completist, and some people might be like, show the assembly, then show the part detailed out, and that's good. That's good. Well, I mean, that's good drafting practice. Sometimes when the assemblies are super simple, I don't necessarily need an additional parts. Um, I don't need an additional parts broken down part. But I mean, normally we would, but where this assembly almost is easy to see the shape of the part as well. And as long as my part description, as long as I can figure all that out, maybe I don't need it. Maybe I can simplify my drawings without having to have a specific, the part broken down. But it depends on where you work and what their methods are, for sure. This is kind of a simplified drawing in some ways. But I was going to open up that, you know, open up one resource I have for this, which is a specific steel. Look, that's just a local company here. They're just over off the North Main extension in Pocatello, and they're in Idaho Falls, and they're in Boise, and they're in all over the Pacific Northwest. They're not all over the country or international, but they're kind of this is just one of the catalogs for materials they sell. Why? Yeah, here's where they are. They're mostly unique products, but they're their own backyard. I love their manual. It just gives me a lot of information on how steel it's designated, which can kind of help me with my descriptions, um, and helps me know what's also like available. They say stock lengths are 20. So here's hot rolled strips and flats. That's kind of a flat bar. Ours is a 1/4 by 6. What they show you though is, yeah, it's always thickness by length, kind of, is or by width here, because the length is always 20 foot. So they don't give you the length when it's caught up. It'd be like, I need to order some 1/4 by 6 inch flat bar. And they would look down here and they'd say, oh yeah, 1/4 by 6 is somewhere, yeah. This is still flat, different sizes, thicknesses. Oh wait, it's up to 1/4 inch thick by 6 inch wide right here. And then what are their little columns? I don't know. Weight per foot. That's how they're usually going to sell it. Steel is usually like fluctuates cost a lot based off the steel price. And so I think they usually base the price off of the weight price per foot, the price per pound. With the stock market, that's fluctuating constantly. So when you get quotes, it's usually like good for 2 weeks or something. So like during the pandemic, it was good for like 2 days. And it was even only available if it was available when you called it, and you probably should buy it. You're not going to. It's pretty detrimental to steel supply. 1/4 by 6 is how I would designate that. And so this is what I want to show you. That's just flat bar. That's how flat bars are designated. And they have a lot of different flat bar, a lot of different thicknesses, up to 2 inch thick. That's pretty thick. And then we have angle iron. That's a real standard stock kind of angle. I just posted this because I wasn't sure. I don't think a lot of you probably have looked through metal catalogs like this, but this is like looking for like just if you're and Lowe's and Home Depot they don't have a lot of steel, right? They have a little area, but you usually have to go to a steel distributor to find steel, and then you have to know like what they carry, and they're huge plant. If you've never been in Pacific Steel here, it's awesome, and they just have like tons of steel, and they can do cutting and all kinds of like manipulation of steel there for you. They could cut things to length for you there too, and a little bit of a charge. But angle iron will be like leg by thickness of the angle. So it's a little bit different. It's like leg length, thickness. They obviously, they can get out to 40-foot lengths here in England. Real common shape for structural applications. Angle iron, a lot of different sizes. And they'll tell you what they can do. They can roll stuff for you there. Then there's just round bar, but then they have all these different categorization of like round bars. Hot rolled and cold rolled. Prices vary on a lot. form too. Hot roll being like the cheapest type of material. Sometimes it's just what they call hot rolled, whether it's hot rolled sheet or hot rolled plate or hot rolled. They're always less expensive. So it's definitely a cheaper manufacturer. And then so there's rounds. These are just solid round bars of all different diameters. Should be by diameter. That's why, like on my flat bar, that's why in my description I only put the sorry, these are angle irons, but I only put the thickness and the width. The length is not something that's normally in the catalog either. If I was designating an angle iron, I do like leg by thickness. And if I did round bar, I'd probably just be putting in the diameter of the round bar, like 2 inch round or 2 inch yeah, round. And I could just write round square they have. Anyway, I'm not gonna go through the whole catalog, but definitely look through this. It shows you how like tubing is designated. And I think Nathan asked, do they have all this in stock? No, not necessarily. They do have a lot of this in stock and the most common sizes. And this just shows you what they can get. And sometimes it's just a few days away. They have like daily trucks that are going between all their plants from the distributor where they're being made. And there is Salt Lake City. I think there is some extrusion operations in Salt Lake. None here, at least none in Boise that I know of. But definitely Seattle, Portland, Salt Lake are probably handling a lot of our like extruding steels. It's a whole different operation. These are sheets, hot rolled sheets and cold rolled sheets, galvanized sheets. Yeah, we'll kind of play with some of these different materials. Some of our stuff is different materials. Some of these assignments are. So channel iron is kind of C, something we call C channel, but it looks like that. But I-beam has its whole different type of designation. When Alicia teaches structural steel, you'll kind of learn how to do that. I don't do a ton of structural here in mechanical. A little bit of tubing. Yeah, again, this is a good sheet. So that's all I want to show you. I'm just gonna like for me to finish this drawing out would be just do the other side, so it looks like our assignment here. And that one's done. Then I would just upload the drawing. I haven't changed my description to upload the PDF, so it's a good habit to do that. Always make a PDF of your drawing, and for sure, I guess I'll just leave it as like parts assembly and inventor drawing at this point. And next week I'll try to write it, change my assignments to say PDF of them. I think I will have you turn in a PDF for the V twin piston and for the pipe support when we get to it, but that's all I'm not. Yeah, today it's a good place to stop.